Hello everyone. In this session of CCNA series, I'll discuss wireless principles and different types of wireless LAN 802.11 service sets such as BSS, ESS and IBSS. A wireless communication usually involves an exchange of data between two devices by using radio signals rather than a wired link to exchange the data. To exchange the data between multiple devices, you can use wireless LAN. Modern wireless LANs are based on IEEE 802.11 standard. WLAN behaves much like a hub, where multiple hosts connect to a shared media, which means a local area network that shares its total available bandwidth with all the connected devices. And it operates in half duplex mode, where a sender can send the data and also receive the data, but one at a time. Wireless communication use CSMA/CA, also known as carrier sense multiple access with collision avoidance. It is a process that wireless devices use to check if the wireless medium is free for packets to be sent between devices. CSMA/CA aims to prevent collisions by listening to other nodes on the same medium and informing devices not to transmit any data until the path is free. Therefore, only one device can transmit at any given time. At the most basic level, there is no such control over the number of devices that can send and receive frames. Any device with a wireless connection can power up at any time and try to communicate. So there should be a process to authorize the user or devices and secure them. This is where the BSS comes into the picture. The 802.11 standard calls this as a basic service set. At the heart of every BSS is a wireless access point. Here the AP operates in infrastructure mode. With infrastructure mode, we connect all wireless devices to a central device, the access point. The idea behind a BSS is that the AP is responsible for the wireless network. The BSS uses single channel for all the communication. The AP and its wireless clients use the same channel to transmit and receive AP signals range defines the size of the BSS, and we call this the cell. In BSS, the AP acts as a single point of contact for every device that wants to use the BSS. It advertises the existence of the BSS and makes it available for the other devices to join. And it does this by using a unique BSS ID, which is based on the AP's own radio MAC address. The AP also advertises the wireless network with a SSID, which is a text string containing a logical name. And it doesn't have to be unique. You can say BSS ID is for machines and SSID for humans to understand. When a wireless device wants to join the BSS, it sends an association request to the access point. The access point will either permit or deny the request. Once permitted and associated, a device becomes a client or 802.11 station. All traffic from wireless client has to pass through the access point, even if it is destined for another wireless client, because the AP is our central point for management. A BSS is a standalone network with a single access point. And you can see there is no connectivity with any other network. What if the wireless client wants to communicate with the devices that are not member of the BSS? An access point supports both wireless and wired connection and can also have the uplink to an Ethernet network. The upstream wired Ethernet network is referred by 802.11 standard as the distribution system or DS for the wireless BSS. Here the AP bridges the wireless and wired layer 2 Ethernet frames. This allows the traffic to flow from the wireless to the wired network and vice versa. For example, if you have network with multiple VLANs, Then each VLANs are mapped with different SSIDs, and for this to work, the AP must be connected to the switch by a trunk link, that carries those VLANs. Here we have a VLAN 100 that is mapped to SSID employee Wi-Fi, and VLAN 200 to SSID guest Wi-Fi. The problem with BSS is it uses a single access point and it cannot cover the massive area if you have a large number of clients. A single access point signal can't cover an entire floor of a hotel or hospital or a large building. To cover such areas, you must need to add more access points and spread them out geographically by interconnecting to a switched infrastructure. The 802.11 standard calls this topology as Extended Service Set, or ESS. The whole idea is to allow the client to have a consistent and seamless wireless service by making multiple APs cooperate. The main point we need to consider here is, in an ESS, the SSID should be defined in all the access points. Regarding the BSS ID, each cell will have a unique BSS ID, but both cells share one common SSID. In an ESS, a wireless client can associate it with one access point, while it is physically located near that access point. If the client shifts to a different location, client can automatically also associate with a nearby access point. The wireless client moving from one access point to another access point, we call this roaming. Another type of service set we have is IBSS, also known as Independent Basic Service Set. Let's take an example where two employees, if they want to exchange some files and are unable to find any access point nearby. The good news is the 802.11 standard allows two or more wireless clients to communicate directly with each other without the need of central device like access point. You can call this as an ad hoc mode or an independent basic service set. For this to work, one of the devices must take the lead and begin advertising the SSID similar to what an AP would do, and then the interested devices can join this network. That's it for this session. I hope this was informative for you. In my next session, I will discuss about wireless LAN topologies or how they operate in non-infrastructure mode. Thank you for watching.